We are in example number 8. We are analyzing impulse and momentum. So here we have a cannon that will fire a projectile. The weight of the cannon is 1,200 pounds or 1,200 pounds, and the weight of the projectile is 8 pounds. And then we are given that the velocity, how the cannon fires the projectile, is 1,500 feet per second. And the firing takes place in 0.03 seconds. And we are asked to find the velocity of the cannon. So as you imagine, whenever I fire the projectile, the cannon wants to go back. It's attached to a spring. As you remember, the spring doesn't create any impulse because it absorbs the impact. We are asked to find the velocity, the impulse that is created, and the average force that, well, actually that spring will receive that average force. If we want to use the principle of impulse and momentum, we have to do an impact diagram. So we do an impact diagram, or what is the same, an impulse diagram, and I will do them together. So I will do the cannon, and well, let's imagine that inside we have the projectile that is going to be fired, right? So we will have the relative velocity of this projectile is given. So we have the relative velocity between the projectile and the cannon. As you see, we don't draw any forces for the spring, we don't draw any forces for the weight. So this is not a free body diagram of the projectile or cannon that has to be in equilibrium. This is an impact diagram, which is different from a free body diagram. So in this case, the impulse that the project received to go out of the cannon is the same that the projectile produced to the cannon. So those are internal forces or internal impacts that we will not draw in our diagram. So if we apply our principle of impulse and momentum, we have the momentum of the final velocities of everything will be equals to the sum of the initial momentum for everything, right? So position 1 is before a fire and position 2 is in the firing of the projectile. So as you see my impact diagram, there is no impact, there is no forces that I see here that I will integrate over time. And before I created any velocity, before the fire, the velocities were equals to 0 as well. So we only have velocities when the fire goes on. So if we expand this summation, when then we have that the mass of the cannon for the velocity of the cannon plus the mass of the projectile, velocity of the projectile will be equals to 0. Remember that those velocities are absolute. What was given was the relative velocity of the projectile with the cannon, but here in our equation of conservation of linear momentum, we have absolute velocities. So this is what is the equation of conservation of linear momentum. Right? And we have here two unknowns. So this is our first equation. Second equation will be that we know that the velocity of the projectile is equal to the velocity of the cannon plus the relative velocity of the projectile respect to the cannon. And this is the velocity that is given. So here we can write that the velocity of the cannon plus the velocity, relative velocity, which is 1,500 feet over second. So we have here, our second equation will be the velocity of the projectile is equals to the velocity of the cannon plus 1,500. So this is feet over second, right? We know. Okay, so this is our second equation. And then we have two equations with two unknowns, so we can solve for them. For the first equations, let me substitute the velocity of the projectile in these equations. So we have the mass of the cannon. This is weight, and we have to use mass. So it's this divided by the gravity. So the mass of the cannon will be 1200 divided by 32.2 times the velocity of the cannon plus the weight of the cannon, 32.2 times velocity of c plus 1500, and that's equals to 0. In this case, we can cancel out that gravity because we only have two elements and both are divided by the same number, and from here we can solve for c, right? Let me write you the number right here, 9.93 negative feet over second. Why is a negative? Because the projectile is going in that direction and the cannon is moving backwards. Okay, so we were able to find the velocity of the cannon. We want to find the impulse and the average force. To find the impulse, we have to make another impact diagram. My second impact diagram, this is step 1, right? My second in that diagram will have to be separated. So what I'm going to do is do the same impulse diagram, but now if I take the projectile out, then I do see the impulse that the projectile is creating with the cannon. So here, this is the impact diagram. Of only the cannon. Okay, so here we do the same equation of our impulse and momentum, but in this case, we will have that reaction force, or that we name it negative, right? Equals, now we have only the cannon, so will be the mass of the cannon, velocity of the cannon, in the second position, the mass of the cannon, velocity of the cannon in the first position. And we said that this was equals to 0. Therefore, my reaction force will be equals to negative mass, velocity of the cannon, and the mass of the cannon is the weight divided by 32.2. Those, actually I put it twice the sign, so this sign doesn't go. So in this case, those signs cancel out, and it means that I put the reaction in the right direction. So when the cannon moves out, that reaction goes out, and that's the reaction is what is moving actually the cannon backwards, right? So, and that will be times 9.93. Finally, my impulse or reaction is equals to 307.20 pounds and per second. So remember that this is not a force, this is an impulse. And if we want to find the average force, as you see, we can imagine for the 0.03 seconds that the firing take place, that force as an average, right? Because as soon as the cannon strike, there's 0, and that's the peak when in 0.03. So we can actually have the average. At the end, we can calculate the force as the reaction or impulse divided by the time that it takes place the firing, right? So therefore, my force or average force, let me call it average force, will be equals to this value divided by, which is equals to 12.3 kip. Okay, so we were able to find the velocity of the cannon, the impulse, and the average force. That average force is the one that is the spring is going to receive. So if further on you want to use these values to design that cannon, those are the forces and values that you will be using.